we have to look at where that goes wrong. And I hope that talking about the interpretation bias, which is the main focus of the reading for today, can act as a organizing structure. So some of the things we talked about in both the second and third block hopefully make more sense or have more clear connections after connecting them to the interpretation bias. So basically the takeaway from the first part is we need to move beyond naive psychology. The scientific method is the way to get us there, but just mindlessly following the steps in this empirical cycle will not necessarily mean that we produce more useful results. So we need to be very critical about the way in which we supposedly test our theories, the way in which we supposedly measure the stuff we're interested in, the way in which we supposedly measure psychological constructs. And that's related both to the second and the third part of the lecture. So a general way in which you could say that reasoning about psychological constructs on the basis of psychological research might go wrong or might be biased is the interpretation bias. So I tried to show you last week that getting from your theory to a statistical hypothesis, testing that hypothesis, and then reasoning about your theory in light of those results are active steps. Ideally, those are active steps that the researcher takes. And you need to weigh in different considerations when taking those steps. But what we see is that people are biased towards getting certain results. People are biased towards getting the results that will keep their initial beliefs intact. So if results from your research are ambiguous somehow, so the test of that hypothesis at a statistical and a research level is ambiguous, can be interpreted multiple ways, people choose the interpretation that fits best with what they thought before doing the research. And that's the interpretation bias. So a bias towards interpretations that favor researchers' theory, both when getting significant results and when not.
How does this differ from confirmation bias?
It's related to the confirmation bias, but it gives you a... let's get back to how it differs from the confirmation bias after we've talked about the interpretation bias, right?
Okay, thanks.
Let's see if it then makes more sense or whether there is indeed a considerable overlap. All right, so it's related to the Klein-Duhem problem that we talked about last week, right? Because we've talked about that ideal way of trying to falsify your hypotheses. Basically, if P then Q and then being able to claim not Q, right? Denying the consequence has logical implications for the truth of the antecedent, and that's the deductive logic behind the falsification principle, right? So if my theory holds, then this prediction, and if you're then able to falsify that predicted outcome, then that has logical implications for the truth or falsity of your theory. But we've seen that we cannot directly derive a prediction from a theory. We're making a host of other assumptions, right? It's all those different steps in that argumentation chain that I just showed you, right? We're reasoning from a theory to a research situation to a statistical test and back again. So there's multiple steps involved. And when you falsify your prediction, so there's no significant results, for example, you don't know which step has been falsified, all of them or just a single one of them. So basically you're saying, well, given all these assumptions about my theory, about measurement, about the context in which I do research, etc., then I would expect these and these results. And if those results then do not occur, you don't really know which part of the first premise has been falsified. It could be the substantive assumptions, it could be something else related to the measurement. That's a very fundamental problem, and Bell and Peters, the writers of the article about interpretation bias, relate that to the situation in psychology. Basically what they're saying is that those substantive assumptions can be summarized as our theory relevant beliefs, right? What do we believe to be true about psychological functioning? And the stuff about assumptions about measurement and research, etc., are our method relevance beliefs. So what do we consider to be proper research and valid measurements? And when you get results that you didn't predict in advance, you can account for that by saying, well, either my beliefs about psychological functioning are incorrect, so that debunks my theory relevant beliefs or part of them, or it debunks some of my method relevant beliefs. The fact that the specific measurement I used was adequate or not in this situation. So to make that more specific, in psychology, the interpretation bias holds that people have the tendency to interpret the failure to confirm predicted results in terms of method-relevant beliefs, but confirm predictions in terms of theory-relevant beliefs. So if something leads to the predicted outcome, then basically we're saying, hey, this confirms my theory. But if the predicted outcome doesn't occur, we're not saying, well, this falsifies my theory. No, people say it must be due to some aspects of my method-relevant beliefs. So it must be due to some aspects of the measurement procedure. So let's try different tasks. Let's do a conceptual replication and see what happens. So this hopefully answers in part the question about how is it different from the confirmation bias. I would say that the confirmation bias is the underlying tendency that people have to confirm their initial beliefs or look for confirmation of their initial beliefs, but the interpretation bias makes that more specific of how that occurs in trying to scientifically test our hypotheses in psychology. Particularly in psychology, this plays a role because those two types of belief we're talking about, theory and method-relevant beliefs, have a specific status which is different from the hard sciences like physics, for example. Specifically, our method-relevance belief, so what we consider to be proper measurement of a construct, is more debatable. It's, in the words of Lebel and Peters, less central or more peripheral than in other sciences. I'm going to try to show you in the next couple of slides what we mean by that. So, let's say you do some research on aggression and you measure aggression by having people pour a bit of hot sauce in a cup, right? And that's actually used in actual research, published research. It's the hot sauce task. I think we talked about it in the first year. And basically, if you measure in millimeters the amount of sauce people pour in a glass, I guess, and they basically say, well, the next participant needs to eat this hot sauce, and it's unpleasant to eat it. And the more sauce you add into the glass, the more unpleasant it becomes for the next participant. They take that as a measure of aggression, right? So that's your dependent measure. Your independent measure is a priming procedure. So you sit people behind a computer screen. This is how a computer screen looked back in the day when computer screens are basically old. And you can prime them, right? So fixate your gaze on the plus in the middle, and then brief masked primes of subliminal primes even of elderly related words would flash into the screen. So let's say you're testing a hypothesis. You're saying, I'm testing the accessibility of elderly related thoughts on aggression towards the elderly. I don't know why, but you have some theory that you're testing this way. And so you're predicting people subliminally primed with elderly related words like granny depicted here will show more aggressiveness compared to a control condition that uses neutral words. That is the experimental hypothesis that you derive from your theory, right? And you're testing that, and you're basically comparing two groups. So you do a t-test, and let's say you don't get a significant result. So your predicted outcome fails to occur. What you can do basically in psychology, it's easier to do this. You can just question the validity of your method. You can say, well, using a hot sauce paradigm isn't the best way to measure aggression in this type of context, right? Or you could say, perhaps the different priming words I used weren't that effective, and I should use a different set of words. So you can basically put up for discussion both the dependent measure as the independent measure. And that's what Lebel and Peters mean by belief centrality. So if I'm concluding as a psychological researcher that hot sauce paradigm or the subliminal priming paradigm, the way I did it, isn't a proper way of going about measuring things or manipulating things, not a lot of people would lie awake at night by that, right? That they wouldn't be bothered by it because it has no impact whatsoever on the way they go about doing their measurement, because perhaps they're not using hot sauce but something else to measure aggression, and they are not using subliminal priming but something else to make elderly related thoughts more accessible. That situation is different from if you were a researcher in physics, or perhaps you can use thermometers in psychology as well. And I don't know, you're basically, let's say you're putting people in two different groups, and one room you raise the temperature measured by your thermometer, and then you predict something about aggression, and let's say the predicted result did not occur. Then it's more difficult to say, well, basically measuring temperature using thermometers is not a proper way of measuring temperature, so let's use something else instead. I don't know, hold up my hand in a room and see whether it feels hot or not. What you see is that if you're, as a researcher, claiming that your measurement procedure, measuring temperature using a thermometer, isn't adequate, that has an impact on the way in which people go about doing research in different domains, right? So measuring temperature using a thermometer is very central in terms of method relevance beliefs, right? Measuring aggression using a hot sauce task is very peripheral in terms of your measurement related beliefs. Because of that, it's easier to basically say, well, predicted results didn't occur because of my measurement, right? There's no pressure from other fields to for you to conclude that the measurement was indeed correct, but therefore your theory must be incorrect. So basically, a thermometer is very central, and if you were to conclude, well, the way in which I measured temperature or mass or whatever was, well, faulty, then if that is the same way in which those measurements are performed in gravity research, aerodynamics, astronomy, rocket science, climate research, etc., you saying that basically you can't measure temperature using a thermometer, you have a lot of to explain to those other fields, right? And that's what we mean by centrality. The measurement procedure is very central in our constellation of beliefs about how we measure things in different fields. And that is not the case for a hot sauce task. That's more peripheral. We do have some general assumptions about how we go about measuring things using an experimental design, but there's different ways in which you can measure aggression, and which you should use, and which the specific way you should go about using that type of measurement isn't that clearly described. So, hopefully that shows you a bit about what centrality means. The fact that our method-related beliefs in psychology are very peripheral gives us more leeway as researchers to say, well, the predicted result didn't occur not because my theory is false, no, because the measurement was incorrect. And you're basically, not a lot of people would agree with you, and you don't have to have that strong arguments for saying that it could have been the hot sauce task that was the cause of the predicted results not occurring. Whilst if you're saying, well, gravity is a lie, as the apple falling from the tree here is saying, you have a lot more to explain to other researchers, right? So, a difference between the concepts we talked about, right, measuring mass and measuring temperature, and measurements in psychology, is that measurements in psychology, measurement procedures in psychology haven't been validated, and so the procedures aren't that unambiguous as the procedures, or precisely described as the procedures in other scientific fields. And that's a downside, because if method-related beliefs are more central, that forces us to be conservative, right? It basically forces us to be conservative in throwing out our assumptions about methods, because that basically has impact on a lot of different fields. Thinking about conservatism is, I thought of this picture and now showing it to you. I don't know whether that makes a lot of sense, but conservatism basically is the ground you stand on a researcher, right? You build a whole constellation of assumptions on which everyone agrees, and if we're just saying on this we all agree, we think that this is a good measurement procedure, this is a good way about way to go about doing research, then you can say something sensibly about the results that occurred, whether that was down to your assumptions not being correct or because it's less likely that it's down to your measurement procedure. So that's what Lebel and Peters means when they talk about methodological rigor and leveraging conservatism. Perhaps you read that and you were thrown off by it. It basically means that if we have those core beliefs about what proper measurement is, the proper way of relating observable behavior to non-observable constructs, then that forces us to be conservative in our interpretation, and that makes it less likely that people fail to interpret a falsification of their predictions as a falsification of their theory. All right, so we've talked about the interpretation bias, right? Which you might call a more specific description of confirmation bias as it occurs in actual research. And we've seen how that interpretation bias, the tendency to interpret results in a way that keeps your initial beliefs intact, is more likely to occur in psychology, because in psychology our method-related beliefs are peripheral. So by now you should understand what that means, right? That our method-related beliefs are peripheral, and how that has an impact on the way in which we decide about our theories in light of our data. Another reason why it's more likely to occur in psychology is the fact that, according to Lebel and Peters, our theoretical beliefs are too central. And basically, I don't think their description of this is very clear, so it's one paragraph at the end of the research article. But basically, it's similar to what we discussed last week, right? So last week we talked about if you get a confirmation of your predicted results on the basis of your theory, we tend to give very specific interpretations to that. So we tend to say, well, that fits with my precise theory, right? And we tend to disregard the extent to which those results might also be in line with competing theories, even general beliefs about human behavior. So I gave the example of washing your hair with a shampoo containing caffeine extract. And you could say, well, look, I washed my hair with such a shampoo and now my hair improved. That might be due to the caffeine extract. That might just be a general effect of washing your hair. So in blue, we have a general theory about shampoos, and in red, a more specific theory that would fit really well with my beliefs as a researcher. But the research results confirms actually both. And the way in which we did research offers us no way in differentiating between the more general beliefs about psychological function, shampoo functioning in this case, and the more specific beliefs. And it would be similar to the way in which psychologists set up their experimental hypotheses, right? So usually psychologists say, well, if my theory holds, then I would expect such and such results in this experiment. But you need to be able to distinguish that specific prediction from whatever you could expect if any general assumptions about human behavior hold, right? So let's just say a general assumption is that people try to follow instructions from the experimenter. Does that already make it likely that your predicted results will occur? Then we do not necessarily need your more specific explanation. Or a better way of saying this would be, your specific hypotheses or your specific theory actually hasn't been tested, because more general assumptions would explain the data as well. I hope that makes sense. That's basically, if you read the stuff about centrality of theory-related beliefs and you're a bit confused about the description in the article, this is basically what they mean, right? On the basis of which we theorize, it's difficult to differentiate between our specific theories and predictions derived from those specific theories and more general beliefs about psychological functioning. So therefore, we have a combination of very central beliefs that are difficult to falsify because they're basically very general assumptions about human behavior. And we have very weak assumptions about proper measurement. So that combination makes it more likely that researchers in psychology, after getting a non-confirmation of their results, say, well, that's due to the theory, right? Because your assumptions about that's due to the measurement, because our theories about our assumptions about methods and measurements are weaker than our assumptions about our theoretical expectations. So far, so good, I hope.
Yes.
All right. That's at least one yes. So far representing the degree of, right? This
yeah,
is
it's very clear. Thank you.
Okay. I take that as I want to make a measurement joke, but I'll skip that for now. Anyway, so we've talked about belief centrality, we talked about the interpretation bias, and there's 3 issues that the authors identify that make the interpretation bias especially troublesome in psychology because of 3 specific reasons. First of all, there's an overemphasis on conceptual replication. Second of all, there's a problematic implementation of null hypothesis significance testing. And third of all, there's insufficient attention to verifying the integrity of measurement instruments and experimental procedures. So the second part of the lecture after the break will be about that third point. We're going to briefly first, before the break, talk about point 1 and point 2. Because we've covered this, but this is an example of how I want to connect to stuff we've talked about previously in this course and what it means for, basically the scientific process. So there's an overemphasis on conceptual replication. As you recall, Bem, for example, wrote in his paper on people being influenced in the present by stuff from the future, that the experimental procedure he finally landed on and reported in his paper required extensive pilot testing. As all research psychologists know, many procedures are tried and discarded during this process. That basically shows you all the stuff we talked about, right? We can be very cavalier basically about the way in which we measure things, right? If Bem says, well, I've tried 15 ways of measuring precognition and 14 of them turned out to be no proper measurements of precognition, not a lot of people would disagree with them because we don't have any specific strong beliefs about what constitutes proper measurement in this domain. And you see that as well in conceptual replications, right? So people tend to be more interested in getting a conceptual replication, right? So if I do a completely different measurement procedure and I get a predicted result as well, I see that as a confirmation of my general theory. But that does nothing to correct perhaps the fact that you found a statistical fluke in your original measurement. But basically the idea that failure to produce significant results, as Bem very openly describes it here, so failure to produce significant results constitute failed pilot studies that end up in the file drawer, is one of the factors that exacerbates that problem of the interpretation bias, right? So because it's very common actually for researchers to say, well, my predicted results didn't occur, so let's toss this way of operationalizing stuff I'm interested in and do something else instead, because that for a long time was very common and part of pilot testing, that might have exacerbated this problem of the interpretation bias. A second way in which we've also talked about already is the fact that null hypothesis significance testing has a problematic implementation in psychology, right? So we've talked about the null ritual last week, in which basically Guy Renzer says the null ritual is that people say, well, my null hypothesis is no difference whatsoever between groups or no correlation, and any significant deviation from that 0 point is seen as a confirmation of my theory. So that's implemented in BEM as well, right? There's no clear reason why we should expect a deviation from 50% correct, right? Choosing the right curtain, left or right. Basically, a chance result would be 50% correct rate. Why a deviation from that 50% correct rate could only be attributed to precognition, right? Paranormal stuff happening. Perhaps there's a host of different alternative interpretations that you could also, would also make it more likely that BEM would find a difference from 50%, especially since he tried out all those different pilot tests that he mentions in his paper. We've talked about the straw target, right? Counter-arguing with an opponent in a debate in such a way that you misrepresent the counter argument in a way that makes it easier to refute. And that's basically what we're doing in this problematic implementation of null hypothesis significance testing as well. Basically, it's a very weak test of a theory saying, well, I'm going to check whether the results that I did get were to be expected given that nothing is going on. And if you do see that that's unlikely, basically my theory is correct. Whatever I'm thinking in advance was correct. That doesn't necessarily have to be true, right? So it doesn't necessarily mean that you get a significant result, that it means that your specific predictions have been confirmed. It could also have been the confirmation, or it could have been even better in line with competing hypotheses. Or perhaps you should put your theory to the test in a stronger fashion, right? And make a more specific prediction and saying, my theory predicts any non-null results. That's a very weak test of theory. But you could also say, well, if my theory holds, only effect sizes between, I don't know, 0.5 and 0.7 are to be expected. That would make your test a lot more specific than just saying, well, it wasn't 0, so I'm basically right. That would summarize the problematic implementation of null hypothesis significance testing, and which should sound familiar to you by now. So two aspects, or two of the three factors we're going to talk about that exacerbate that interpretation bias in psychology, which is an over-reliance on conceptual replication and problematic implementation of null hypothesis significance testing. The third one is insufficient attention to verifying the integrity of measurement instruments and experimental procedures, which is a mouthful, and therefore we're going to cover that at length and in a bit more practical, applied manner in the second part of the lecture. For now, relating it to the BEM research on precognition, you could argue that, well, a lot of the measures that he uses are very ad hoc. So, for example, his core results about a deviation from 50% chance only occurred for women that scored high on extroversion. And extroversion was measured with a type of measure, not an actual proper personality measure that would take hours and hours to complete, as Danny indicated before, or Han, I misremember. But one or two questions that he thought up on the spot, right? I'm basically summarizing here. So that is an example of taking insufficient effort to verify the integrity of measurement. Is measuring personality or extroversion in this way actually a good way of going about things? Or why would you use curtains at all, right? So choosing between two curtains to show you what the effects of stimuli from the future are on the past. I mean, that's such a weird thing to believe that you at least need to specify what that connection is, which it isn't. So that in the context of BEM's research, it should be clear how there's insufficient attention to verifying the integrity of measurement. But it's easy to take potshots at a theory about the future influencing the past, of course, because it, on an intuitive level, it doesn't make sense to read research results that say the future influences the past, at least for most people. So perhaps we need to be more critical and apply that way of thinking to other more common measures as well, which is what we're going to do after the break. So basically what we've done so far is using BEM's research results as an example of what might go wrong in the way in which people reason about the relationship between theoretical beliefs or the constructs we're trying to measure and their actual measurement procedures. And the way in which they reason about it is a lot of the times in a way to keep their initial beliefs intact, which we call the interpretation bias, and we've talked about different factors that exacerbate that problem. But in a similar way, we can have a critical view of, or critical perspective on how people supposedly think about the stuff they're interested in, right? In BEM's case, it's precognition, and they're trying to measure that construct, that stuff that we can't directly observe on a basis of measurement, the percentage of correct decisions that people make. And we can be critical about to what extent that percentage directly has implications for the underlying construct. But in a similar way, we need to use those critical thinking glasses and look at very common ways of doing research, right? At the beginning of the lecture, I talked about that Excalibur way of thinking about science, right? That you as a scientist get to wield once your training is complete, the awesome tools of the scientist, and the whole message of this, or you should be reluctant in being overconfident in your results, because we know of that interpretation bias, right? So even if you're wielding the awesome tools of science, like survey research or fMRI research, or perhaps an implicit association task, you need to be cautious in interpreting those measurements as reflecting the underlying construct you're interested in, because of different thinking biases that we'll talk about more specifically after the break.